So let's begin our today's session. Before starting with today's session, can I get a quick confirmation that you are able to hear me and also see the voice, see the screen? The screen should say Python control structures. Is it visible? You could type in your chat boxes. Okay, fantastic. And do you have any queries or doubts until now? Any of the stuff that we have covered, if you have any queries or doubts, feel free to ask them. Since it's been a week, right? And we had covered just one class yesterday. All right, so never mind. You could ask the questions at the end of the session. So today we are going to look into what control structures and iterators are. Let me bring up a screen where you should be able to do it. I am going to use an editor called Sublime Text for running the code. So here, let's understand how Python would be working with iterables. Very first thing that you need to understand in Python is that Python does not have any semicolons. Okay, Python is not a big fan of parentheses, neither it is a big fan of curly braces. So in C, where you would be writing programs like this, void main, and then you would be starting your function body, and you could write something into it, some blah 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 kind of thing, and after every line you would be placing a semicolon, right? And then at last you would be, if this is a function, you would be returning something. Since that's actually void, you wouldn't require to return, but if I change it to int, in that case I would be returning something, and that would again be a function like this with a semicolon, correct? But okay, if I want to convert this into a Python code, in that case I would be writing something like this: def marks the start of the function body. Okay, then it is going to be function name, so in this case it's main. All right, parenthesis in the function declaration, and a colon marks the beginning of any of the function body. It could be any of the code block rather. So it could be a function, it could be a if else statement, it would be a loop. But when the code body starts, so anything that I'm going to place here beneath the main, it's actually going to be a part of the main function, right? So that part which I'm supposed to be making part of the main function has to be one tab indented inside the function. It cannot start from here, it cannot start from the def itself. It should be one tab indented. Either you use two spaces to indent or you use four spaces to indent it. Okay, by default we use four spaces to indent that. We don't use tabs generally, but you could use a tab. Make sure that whenever you use any indentation standards, either two spaces or four spaces or tabs, you follow it all across your project. Okay, so you don't need to like if you are using two spaces on the first line, then you use four spaces on the next line to indent, or instead of spaces you use tabs somewhere. That wouldn't work. Python would give you an error for those kind of things. So here code block starts with a colon should be there on the very first line, then all the supporting lines should be one tab indented. What if it is a nested if else structure? So if it is a if else structure which has syntax like this: if expression, again colon, because the if block is supposed to be starting now, that belongs to the if, then it should be one tab indented inside the if. Else colon block again dot 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 dot, which is some lines. Okay, how do you end it? Simply place a line which is not indented inside of else, and that would end the else. What about the function? Simply place a line which is not indented inside the function, that would mark the end of the function. So next time if I write something here, print xyz is actually not going to be a part of function, it is going to be outside the function. Okay, makes sense. It could be a little bit confusing, but if you are a good code writer and you have practice of tabbing all your code properly and making it nicely indented because it looks beautiful, in that case you wouldn't be having any problem porting yourself to Python. But if you are not in a good practice of writing code like this, then you might find yourself a little bit in trouble, okay, because Python needs that to understand which block belongs to which particular code section. Let's say I'm writing a if else structure now. I wrote it like this. I have got two numbers, num1 equals to some value and num2 is having some value. I want to check whether number 1 is less than or it is greater than or it is equals to the num2. Okay, so I'm writing a simple if else structure. It is structure is if. In other languages you would be finding parenthesis here. There is no parenthesis here in Python. I would say if, then the expression, let's check for the first expression, less than expression. So it would be for num1 is less than num2. Operators are exactly the same. Code block starts with a colon. Okay, I need to write if number is less than num2, print less than. Okay, then how do I place the else block? Else block should be one tab, non-indented. It should be outside. Okay, there it goes. Else print greater than. What about the third condition? It could also be equals to, right? So for accommodating that, there is elif statement here. I could also write elif. Then the syntax is again the same. Elif expression and colon. So elif num1 is greater than num2, print greater than, else print equals to. Makes sense? Always remember that there has to be a colon for starting of the code block. The code block has to be one tab indented inside of the starting statement. Always. If you fail to do so, let's say I say print hello, but mistakenly I un unindented outside the else statement. I want that to be a part of else, but I simply fail to place a tab before it. So what would be the answer now in this case? Anyone? I just wanted to guess. No one? Come on, people, I want you to guess it. Yeah. So, yes, Krishna, that's the correct answer. The answer is that along with the output, whatever it is, it would always append hello. Okay, that's a good shot. And it's very, very close to the result. Actually, it does not append it. It would be printing hello. And in Python, it prints the other way. I'll show you how it does. It would not append it, but rather place that output on the next line. So here if I execute it, the output is less than. Okay, so whatever the output is, and hello appears on the next line. The reason that happens is uh, the print statement that is used in Python automatically adds a new line character to the end of the string, end of the statement. Okay, it would automatically take care of appending the new line character. What if you don't want a new line character? If you don't want a new line character, you could place a comma after the statement. If you place a comma, in that case new line character will not be added. Okay, and that's when your hello would be actually appended and not occurring on the next line. So if I execute this program now, hello is appended to your output. So brilliant. Thank you. Um, okay, so we have seen the if else statement, but how to make it work. Now, I want to write a program that would print this kind of pattern. So that's very simple, right? We usually did that during our college days. And I want this to be dynamic. So if the user gives me value 5, I should be getting a structure like this. I wouldn't mind if there is a space in between. Very simple. How do you write it? So let's do one thing. I would be telling you multiple things whenever they are required. So if I want these 5 lines to be present as a comment, you know that slash and star doesn't work as comment block here in Python. So what you would be doing is 3 quotes. Instead of 2, place 3 quotes, and that should treat it as a comment block. Okay. Otherwise, single line comments are placed using hash. Hash hello is a comment, one line comment. For multi-line comments, you place that block inside 3 different quotes. Okay. So if I want similar output, I would be doing this. While, remember the structure? Very first you need to initialize. So I need a row counter. So I say where row is 0, it should move from 0 to whatever the max value is. So my user would be providing me with the max value. So I would say the max row would be 5. So let's take it 5. Okay. While, so I say while row is less than max row, correct? Print something. So print what? Print star. But just printing one star would work. Um, what do you think? Wouldn't work, of course. We also need to increment the row so that it does not end in the infinite loop. Okay. Alright, shorthand operator. When you have something like this, row equals to row plus 1, in that case you could use a shorthand operator to convert that into a compact notation. So the compact notation here would be row plus equals to 1. Okay. Similarly, it works with multiplication, division, mod operators, strict division, subtraction, anything. Okay. Similarly, so it would be minus equals to, multiplication equals to, slash equals to, double slash equals to, mod equals to. But make sure that the variable appears on both sides of it. Okay, that's when you use the shorthand operator. So row plus equals to 1 is equivalent to row equals to row plus 1. Alright, so would it work now? Still wouldn't. Let me show you what the output is going to be this time. Alright, so I need 2 loops. That's what I guess. Correct? So everyone is aware of the logic. We place another loop inside this while loop. We write while, and then we keep an incremental counter. We say while my count equals to 0, count should be less than row, and then print star. I don't want it to be on the new line. Okay, so for that we would be doing one thing. Oops, that went in infinite loop. Let's fix this. Okay, so make sure you never end up in infinite loop when you're working with the editors. And here I need count plus equals to 1. Okay, but still on the same row. So what do? I want it on the horizontal line, so I would not be adding a new line character. Great. But I want to place a new line character in between whenever there is a new row appended. So I would say, okay, now we want to do something like print nothing. When you print nothing, you would be printing a new line character. There it, there it is. Okay, so make it 6 to have 5 stars. All right. But we are working with Python, right? There has to be a smarter way of doing this thing. So let's do it in a smart way possible. I would say print row or print star multiplied by row. So I want to repeat the stars row times because the logic is very simple. First row 1 star, second row 2 stars, third row 3 stars. So can I multiply the stars along with the row? Yes, you can. When you multiply 3 by 3, it becomes 9. But when you multiply a by 3, it becomes 3 a's. Okay, still I'm able to get the similar output. Let's place a space. There it is. So Python can help you when writing concise and smaller code. Okay, let's write another program. Here I want to have just a number list. Instead of row, I will be printing just the number. So I would say print row. So it gives me numbers 0, 1, 2, 3, 4, 5. And what about if I want to write a table? Then in that case, you would be writing something like this: print row multiplied by something. So maybe you want to write table of 3. So you'd be writing this, execute it. So you'd be getting a table of 3 onwards. But if you want to format the way it is appearing here on the screen, you'd be doing something like this. I want a program to type the tables from 2 to 10. So I would say my row starts with 1 now. Max row is 11. Or if I say 10, I will have to modify the logic here, right? Row is less than max row. Okay, now that's about the rows. What about the columns? My column starts with 1 again. It starts with 2 because we want to have table of 2, right? And while my column is less than equals to 10, I would keep on printing. So I would say print what? Print row multiplied by column, which is going to give me the table output. And I don't want to uh, place a new line character, so that should be it. At the last, I would be printing a new line character outside the loop. Okay, so would it give me the correct answer? No, we haven't incremented the column, right? So column plus equals to 1 should take care of incrementing the column now. What did I miss? Can someone help me here? It says invalid syntax. What's invalid here? What do I miss? Column. Okay, Bharat says that it's a column. Well, I'm not sure. Column or colon? Perfect. So that's a colon. Okay. So I'll be placing a colon. After a while, let's try to execute it. Okay, that works fine. But what about the formatting? Formatting is rubbish. We wouldn't be able to figure out that the last 20 actually belongs to this 10, and it would be going till 100. So let's make it more clear. We could use some formatting operators here. So what I could do is, if you are aware of formatting operators in Java and C, it looks something like this. %d, right? And then you could place a mod operator here, which would be overloaded. If you place a mod operator between the values and a string, it would be treated as a format operator. Okay, so here on left side I would be placing a string, and on the right side I would be placing the values that has to be implemented inside of the string. Now the format operator %d belongs to integers, %f belongs to float, %s belongs to string. So here I want all the integers to be placed, so I would say %d, but it still is not going to help me with the formatting. So what I need to do is add buffer or pad it. So for padding it, I would say %5d. Every result should be having 5 characters, whether or not it belongs to that particular result or not. So if it is 100, it should be tabbed. It should be padded twice. If it is 2, it should be padded 4 times. Now it looks better. If I want to pad it on the right hand side instead of the left hand side, place -5d. Now execute it. Now it's all indented on the left. If you want to indent it on the right again, remove the minus sign, and it is all indented on the right. Right? Similarly, it happens with the float values as well. I could write -5f or 5f to generate the float values, but float values would also have decimals along with it. So what do I do with the decimals? I would say I need just one decimal. So I would say 0.1. That's how it looks. If you want 0, I don't want any decimals, that works too, just fine. Not interested in f this time because we have just numbers, integers, so this is going to be the answer. Looks better. Okay, so this is how you write concise programs. But if you want to be more concise, we will not be using while. I would be using a function iterator called as for iterator or for loop, and for makes our lives even more easier. Remember that in while we used initialization of the variable, then the condition, then the increment, and in beginning and in the between of them we wrote something like, okay, let me write it here. Count equals to 1. Then we wrote for printing the star program. Okay, while count is less than 6, and then print star multiplied by count, and then we need to do count plus equals to 1, right? And that's how we get the star program. If I want to make it more concise and more readable, I could say something like this. Okay, so let's comment it out. So I'm commenting this part first. There it goes. And now when we are typing the for program, I would type it like this. Very first we need to understand one function. Now there is a function called range. Okay, the function range, the function call has to be made like this: function name and then the parenthesis. The function range would give you a list of numbers starting with the range that you provide. okay, which is initially 0 by default. If I say give me numbers till 10, it would give me the numbers from 0 to 9. Okay, so if I say that give me the number till range 5, it would give me 0 to 4. Now see that we want to print stars. First row should be having 1 star. That means if I multiply it by 0, I will not be getting any stars. I want 1 star. That means the range should be starting with 1. Okay, and we know that the last element is not counted here. If I say 5, it gives me till 4. So I say 6. So I should be getting the numbers from 1 to 5. Now I'm going to use this function in the for loop. What for loop says? It says for every element or number in the output of the function range colon print star multiplied by number. Does it get an answer? Yes. If I want to make it more, I would say 6. It would give me a better result. So what the syntax is? The syntax is for every variable which is going to be assigned in a loop, that is going to be automatically assigned in iterables. Now these iterables could be a string, or that iterable would be a list, or that iterable would be a tuple or a dictionary. Okay, currently we are using a list. Range would actually return a list or an array of numbers. Okay, for now let's make it very simple. Range would give us an array of numbers, and the for loop would be helpful in iterating over the array. All right, if it is a string, in that case also it would work. Let's say I want to get or traverse through all the characters in a particular string, then what I would be doing is I would write it something like this. So for this for loop, let me copy it over, and it goes inside the comment block. So if I want to iterate over a string, so I would say every character. Now this part here, for every variable part, you would write your own variables. Okay, and remember that the scope of this variable is going to be outside the loop as well. So after you finish the loop and you try to access char, it would be holding the last value of that particular variable. So I would say for char in string, so what is str1? Str1 is holding some value alpha colon. For char in str1, print char. So it would give you 5 separate characters separated by new lines. ALPHA. Understood? That's how we use for loop. It's very simple. For every element in the iterable, use that variable inside the loop. So either you could print it, you could add it, you could give a call to some other function, do whatever you want to do, but the scope limits to this. As well, you could print char outside the function once. So that would give you an extra A. Okay, so the scope for loop and while loop is not limited to themselves. They the variables that you use inside of it would be used outside of it as well. Okay, but that is not true in case of functions. So let's see one thing. Since we have covered if statement, else statement, elif kind of structures, then while loop and for loop, now it's time to move to another one, which is called functions. So let's cover the function part here. um, I'm not going to talk of lists currently. We would write a particular problem, and today we are going to we would be optimizing it rather. Okay, so the problem here is I want to calculate a Fibonacci number series. So that's the problem. The problem is write a program for calculating uh, calculating nth Fibonacci number. So if I say first Fibonacci, it would give me 1. If I say second Fibonacci, it would give me, what's the second Fibonacci number? Anyone? Okay, so the list goes like this. If you see the list like this, it is going to be a Fibonacci list. And what is the peculiarity of it? Every number that you see on the right side is actually the sum of two numbers which fall on its immediate left. So if I talk of 21, it is sum of 8 and 13. If you talk of 8, it is a sum of 5 and 3. If you talk of 3, it is a sum of 1 and 2. Okay, and so on. So if I say that I need fourth Fibonacci number, it should give me 5. If I say I want sixth Fibonacci number, it should give me 13. Okay, can you think of any logic? I could wait for a couple of minutes and then we would be starting over. Anyone, anything that is popping in your head, feel free to unmute yourself and talk. If you want to type it here, you could type it here, but I would prefer to talking because typing takes a lot of time. That's tedious as well. Anyone who wants to suggest their ideas? Okay, so let's take it up mathematically. I already told you the solution. The solution is, let's say I'm talking of nth Fibonacci, right? So Fibonacci of nth number is actually equals to Fibonacci of n minus 1 plus Fibonacci of the n minus 2, correct? So if I'm talking of 21, which is Fibonacci of 1, 2, 3, 4, 5, 6, 7. Talking of 27, it is going to be like this. Fibonacci of 7 is actually equals to Fibonacci of 6 plus Fibonacci of 5. Any doubts until now? Is it clear? That's a simple math, right? So if this is okay, I'm now going to convert this into a functional representation. Okay, everyone is with me? Come on, people, you have to respond because there's no way for me to understand whether you are getting it or not. Things are going to get more complex from this point. That's why I need a confirmation. I would be talking of recursion using functions. Okay, assume it to be yes, and I move ahead. Um, so, how do we define functions in Python? So now that we know the logic, I'm going to convert that into functional representation in Python. Functions are written like this: def, starting with a keyword called def, space, the function name, fibo, okay, and colon, of course. Then there should be some logic. So I would say print 21. Let's write a program, very dumb program that you would laugh at, but it would make initial sense for me. So I would say pass n number, okay. If n equals to 1, then I would return 1. And if n equals to 2, then I would be returning 2. And if n equals to 3, I would be returning 3. And if n equals to 5, I would be returning, sorry, if n equals to 4, I would be returning 5. And if n equals to 6, return 8, and so on. Okay, so that's the dumbest program. I have not written any logic inside of it. How to call this? So since this is a function, I want to call a function. Now this function is not printing anything, it is returning the value. So when any function returns a value, you should be able to catch that value, right? So I could catch it like this: my result equals to fibo of fifth number, and then we print the result. Make sense? Very simple functional representation, everyone knows it. Execute that. It would say fibo of 5, print fibo of 5. It's trying to return something and the answer is none. The reason is we haven't placed anything. So it should be like this: n equals to 5, return 8, then we would be getting the answer as 8. Okay, not a smart answer. If I want n equals to 10, in that case I'll have to literally calculate it. This thing wouldn't work. I just wanted to show you how to make a function call when the function is declared. You could directly print it though. You don't have to store it into variable if you don't want to use the variable. Why to waste a space in memory? This should also give the similar answer. But now we are going to place some logic. So whenever you're talking of recursion, we are talking of three things. There are three rules in recursion rather. First rule of recursion says that the function should give a call to itself. Okay. Second rule should say says that whenever you give a call to the recursive function or make a call to the function itself, it should move towards a base case. And every third rule says that every recursive function should have a base case. Now what are these three rules? So rule number one, there should be a call to function itself. So let's follow the rule. I say, all right, I will be following that rule and I am going to return some value which is fibo of n minus 1, and we saw that already mathematically that this is true, n minus 2. Okay, I'm giving a call to the function. That's rule number one. What happens if I don't follow the rule? The second and third rule. If I don't follow those two rules, what would happen? Okay, so it says maximum recursion depth reached or exceeded. You're not allowed to give infinite calls to recursion. That would flood your memory. Okay, so that's rule number two we have not followed. Rule number one works. What about rule number two? Rule number two says that you should be having a base case. Okay, what is a base case? Base case is the final limiting case in recursion. Okay, so in my case, here the final limiting case should be 1. There is no numbers below it. So I would say if, okay, let me write it here. If the number n is less than 4, in that case, straight away return the number. Would that work? If I pass 3, I need 3 out. If I pass 2, I need 2 out. If I pass 1, I need 1 out. Okay, should just work. Alright, so that's my base case. What about the third rule? The third rule says that every time you execute the recursive call, you should move towards the base case and not away from it. So here, whenever I give a call, a recursive call, I am always uh, decreasing the n count. So eventually I'm getting towards the base case, which is 1. Okay, so I'm satisfying all the 3 rules of recursion, and I should not get into a recursive loop now, and similar answer is presented, which is 8. Now that answer is calculated with recursion. We have not got a if-else structure into that. What if I pass something else? Let's try with 7. Okay, that worked. 7 gives me 21. I could easily calculate that for 30 now. Should give me some answer, right? What about the same function if I try to calculate that for 35? It would take some time to calculate. It says finished in 2.1 seconds. What about 20? Does it calculate it faster? It calculated that in 0 0.1 seconds. It calculated 35 in 2.1 seconds. So the complexity of our algorithm is much higher. It is actually in exponential form. Okay, so I don't want it to be exponential. I want it to be a straight line. So I want to optimize this function again, so that if I type in something like 40, it should not take forever to calculate the Fibonacci number. Now let's wait for this Fib 40 to finish. It would take a lot of time. So I'm showing you what the problem is going to be, and we are going to look into the solutions after we cover the iterables part, which is going to be, wow, it took almost 21.3 seconds. So that's exponential. I have simply added five values to n. N was 35, we got 2 seconds. N is 40, which is just 5 more than 35, and it is taking 21 seconds. Now you cannot imagine if you make it 45, how much longer it is going to take to calculate the Fibonacci number. Well, to make it faster, I need some kind of solution here, and the solution would be to store the intermediate results somewhere. And to learn that somewhere, we need to find what iterables are and how do we keep associative values into them. So I will keep this function somewhere, rather I keep it in memory. And now we are going to learn a little bit about iterables, what iterables are, okay, and how do we use it. There are more things to functions, of course. There are keywords, keyword arguments, there are positional arguments, there are references, they are passed by values, and all those kind of stuff is there, but just one thing at a time. Okay, we will not be getting into the complexities right away. Basics first. We are going to learn about iterables. What are these? Iterables are actually data structures that allow you to traverse them. Here in Python, there are 4 such kind of structures that can help you do that. Very first, you have seen string, short form str. Then there is list. Then there is tuple, and then there is a dictionary. You could also include set into this list. Okay, so what are the differences here? Let me write it down. Str, it consists of all characters. Okay, so that's all characters. You cannot have objects in between the strings. Strings are marked in quotes, so that's how you declare a string. You could place digits as well as characters as well as special characters, anything into that. So I would combine all of them into one single character attribute. Okay, so you know what string is, you are aware of it. Can I change the string in between? Can I say something like that? That let's say I have a string like this, s equals to alpha, and I want to change it. So can I say s of 0, which is the zeroth index, and everyone knows that string can be iterated like this. It's an inbuilt form of array rather. If I do it like this, it would not work in Python. Okay, it works in C perfectly fine. It does not work here in Python. It says that strings are not mutable. You cannot change the state of the strings once they are defined. That's why strings are also called as constants, iterator constants. So here, strings are not mutable, so they are immutable. Okay, I would give you an example of all of these things and compare them on the console, but this screen is just for comparing the different properties that you have. List is a variable list of objects. So it could contain a character, it could contain a number, a float value, an object as well. So lists can contain objects. List can contain different lists inside of it. Okay, so I would give you an example of a list very soon. But lists are defined using square brackets. So I could have a list like this. Okay, that's the simplest form. And lists are mutable. They can be changed. So I could call a list, give it some index, and change the index to something else. That works. Okay, so that's mutable. What about tuple? Tuple is exactly same as list, except that you cannot change it once it's declared. It's immutable and it is declared using parentheses. Declarations are different, right? In strings you declare it using quotes, in list you declare it using square brackets, in tuples you declare it using parentheses. In dictionary it's same as list, you declare it using a curly brace. It's mutable, but a dictionary is holding not just values, it is holding keys and values, something like this. If you are aware of associative arrays in Python, not Python, sorry, PHP, this is the same thing. Or JSON objects in Java, so it's very close to that. We have got keys, and every key would be pointing to a specific value. Okay, A points to 1, B points to 2, C points to 3, and it is immutable. So I could say my dictionary key C should be pointing to 4 and not 3. Remember that I'm talking of pointing to, because yesterday we have seen that Python stores everything as reference. It does not hold the value into the variables itself. So I could change it, and that's mutable. What about the set? Set is same as list, but it contains a unique list of objects. You cannot have repeated elements in the set. So just like a mathematical expression, if you say that I have a set of numbers from 1 to 10, I don't have 9 repeating twice, or I don't have 5 repeating thrice in that particular set. I would be having every number defined just once. And we could have set like operations here, since Python is a language that supports mathematical calculations as well as scientific calculations. It would help us in talking to sets. So you could say something like set, let's say A is a set, okay, and B is a set. In that case, you could find the difference like A minus B. You could find the union like A plus B. Okay, makes sense. So you could have all your differences, unions, or intersections calculated using sets. So it will be looking towards these operations when we get to there. So let's take each one of these and try to understand the operations on it. So for this example, I need the console. So I would be jumping back to my Python console here. So let's bring it up. Um, I hope that's visible. Okay, so that's my Python console. If I have a string, which is alpha, I want to change the first character of it to capital A. Okay, and I want to store the same value in S. So I cannot do S of 0 equals to capital A. Since that's an iterable, we could easily use indexes on top of it. So since this wouldn't work rather, but if I say S of 0, I should be able to access that element which is present at 0th index. Indexing in any of the iterables would be starting at 0. It would not start from 1. So S of 0 is A, S of 1 is L, S of 2 is P, H, and last one A again. What if you try to access the key which is not present? It would give you index error that string index is out of range. Okay, we'll see how to handle these things, how to handle the errors, but first you should be able to understand what iterables are and how they work. If I want to iterate over it, I've already shown you using for loop, you could do that very easily. For every character in the string, print the character. So let's say for every character in string, print the character, and there's your answer, alpha. Okay, um, that's the method. Since everything is an object, string is also object, your variables are also objects here in Python. You could call methods on it. Every single object type, which is actually S is object type of str, string. So you could call methods here, upper, then there is lower, then there are many more methods. We will be talking of these methods whenever we need them. For now, it's important to understand that you could call methods on these data structures that we are learning. So string here is also a data structure. Then there is a nice slice operator which is being used. Okay, slice operator helps us in calculating the substrings, inserting inside the string, or trimming it from the left hand side, trimming it from the right hand side. All these operations become very easy when you use it using the slice operator. Okay, what is a slice operator? You know that S of 1, okay, let me write a different string this time. I want a string which is completely different, and I started with 0. The reason why I'm doing this is I want to make sure that when I access S of 0, it should give me 0. When I try to access S of 9, it should give me 9. So S of 9 in my case is going to be 9. Alright. So simple string which has got characters 0 to 9. Now if I want to calculate a substring, I would say I don't need just 5, I need the elements from 5 to 9. So how do I do it? I would be simply marking it like this, 5 to 9. Now what happened? 5 range here is inclusive and 9 is exclusive. So 9 is never included into the result. Just like in case of the range function that we have seen. Range 5, it would give you the numbers from 0 to 5 but not 5. So just in this case, if you know what you're talking of, if you want it to range 10, you could write it like this. But remember that it would work, but if you try to type it something like this, okay, that's going to be a problem because you don't know how long the string is going to be. Every time you change the values, you would get similar results. So how do I know which value to insert? If you're getting confused, don't place anything. So starting from 5 and I don't know where to end, so it would be ending to end of the string. Make sense? If I want the first 5 characters of the string, so I would say start it from the beginning and give me the 5 characters. Okay, so this would give the 5 characters from the beginning of the string. Starts to 0, calculates till 4, 0, 1, 2, 3, 4 are total 5 characters. Similarly, if I want the character 4 and 5 in between, so I would say I want the character at index 4 and I also want the character at index 5. So since we know that the second element here, that whatever we place is not going to be included, we place it plus 1. So S would start from 4, would end on 5, so I should be getting 2 characters, 4 and 5. Okay, so that's a good method of using slice operators. You could calculate the substring, you could calculate the beginning of the string and get some characters from there. You could have the end of the string and have some characters from there. Python also supports negative indexes. So if I type in -1, it would start calculating it from the right hand side. So -1 would give you first character on the right, -2 would give you second character on the right, -3 would give you third character on the right, and so on. You could also access the array from the right hand side without knowing the length of it. Okay, you don't have to do something like length -2, length -3, length -4 to calculate the last but one and last but two characters. Here it becomes more easier. Okay, so we have seen the slice operator here on string. Um, Now let's talk of the list. List is again a data structure, so it is implemented using objects. If it is an object, it would have its own methods. Okay, so what is a list? List, I would define it like this using square brackets. Okay, strings using quotes, lists using square brackets, tuples using parentheses, dictionaries using curly braces. That's what you need to remember. Okay, it becomes very tough to identify just by looking at it whether it is a list or a tuple if you don't know the differences between square brackets and the parentheses. So here L is my list containing a few elements into it. Okay, so this is a list that holds a few integers. Okay, so it is not a string representation now. The string representation, when we saw it using here, the results were all in quotes, but now the results are placed in square brackets. What is the type of it? You could check always the type using the type function. So type of L, it is actually a list. What is type of S? It says its type is string. Okay, does this work? L of 0? Yeah. L of 1? Similarly, just like strings, no problems with that. But the difference here is it is mutable. I could change it. I could change the state. I cannot change the state of S. That's immutable. It says that the str object does not support item assignment. You cannot change it. What about list? Instead of S, if I type in L, would this work? No problems with that. That should work. And this time, instead of 0 at the first index, you have got capital A. So this is a variable list. Okay, you could place any element or any object at any single point. Initially, I had integer placed there. Now I have a string placed there. Next time I use it, I would be placing some different list at all. So let's say if I want to place a list at position 5, so I would say I want to place a list, a very small list at position 5. That list should contain some characters. The characters would be A, B, and C. There it goes. So instead of writing 5, it is now showing you A, B, and C. Okay, that's where the things start growing complex, and you now have a multi-dimensional list. But it's not mandatory to have the same dimensions on all the different elements. What I mean to say is, when you define multi-dimensional arrays in C or even in Java, in that case, you need to have the same number of elements on each and every row and column. So if I say in C that I want to have a multi-dimensional array A, which would be like this, int 3 by 4. So if I write something like this in C, it would give me the results like this. A would be a list, okay, and it would be something like this where there would be 3 rows, and every row would be having 4 different columns. So if I place identical, not identical, different elements into that, it would look something like this, right? 1, 2, 3, 4. Then it would be some more numbers to it. How do I write it? 1, 2, 3, 4. Then there would be 1, 2, 3, 4. Then there would be 1, 2, 3, 4. Okay, that's how it's going to be represented in memory. But here in this case, that's not mandatory. My first element could be a single character. The second element could be integer, whereas my fifth element is holding a list in itself. So it's possible because in Python we store everything by references, and everything in a list is actually an object. That object could be anything. So you could place another list inside of a list. Multi-dimensional arrays, but you don't need to waste space if you don't need it. Make sense? So you use multi-dimensionals only when you require it. So now you have seen that you can modify the list. What are the methods that you could call on it? You could say delete, you could say insert, you could say append. So let's do one single operation. I want the list to be appended and I want to add another element to it. So let's say I have a list containing 2 elements, 1 and 2. That's how my list would look. And I want to add third element to it. So I would say l.append a third list, or element 3 to the list. Now L looks like 1, 2, 3. If I do the same thing and I want to add 4, it would give me 1, 2, 3, 4. Plus operator can also be overloaded with objects, any of the objects. If you want to overload the operator, you'll have to define that inside the object. I'll show it when you cover the object oriented part here with Python. So let's do one single simple thing here. I have 2 lists and I'm adding another list to it. That gives me a bigger list which is all combined together. So currently L holds 1, 2, 3, 4. If I do L plus 5, 6, 7, which is another list, that would add to L and it would give me the answer 1, 2, 3, 4, 5, 6, 7. Make sense? Similarly, you could also minus it. And multiplication operators, I guess there is another library that you should be using, NumPy, which is really a good one. Uh, let's figure out the basics first and then we'll see how to use the libraries also. What's the difference between a list and a tuple? I told you that there is no difference except that lists are mutable. You could change the elements in the list. In the tuples, you cannot. Okay, let's see an example of tuple. Type of L was list. Now I need a tuple. I would represent it using a T, and the tuple holds a few values, and declaration is using parentheses, not square brackets. So the type of T is going to be type tuple. Can I access it using the indexes? Yes. Can I access it using a slice operator? Yes, you can. Slice operator, by the way, would be implemented using the same operations like we did on the string. Everything works. It works on lists. It works on tuples. So it is just like the lists. But can I do something like this that we did with lists? No, you cannot. It says that the object does not support item assignment. You cannot change it once it's defined and declared. Uh, so if that's the case, why do we use it? Where do we use it rather? We use tuples for multiple assignments. Okay, the multiple assignments as in, let's see the program for swapping. You know the program for swapping, right? X equals to 1, y equals to 2. After swapping these two numbers, I should be getting x equals to 2 and y equals to 1. Everyone knows that, right? And there is a small program for that. Use a temp variable, assign it to the temp value, then reassign it to the variables and so on. Let's not get ourselves there. I would be doing a simple thing here in Python. X comma y equals to y comma x. So we are doing multiple assignments. What does x hold now? 2. What does y hold now? 1. So swapping has been occurred, and there are multiple assignments happening. Y went to x and x went to y. That's what happened here. How can tuple help us do it? So if you look closely at this syntax, x comma y equals to y comma x, actually we are using commas in between. Okay, so I could do it the same way, but using parentheses. Now you get more clear idea that I am actually using tuples on both the sides. Okay, so tuples support multiple assignment, and that's what is important. So your tuples can help you return multiple values from within the functions. We'll see that in the coming slides. But here um, we are looking towards the swapping operation. Tuples cannot be changed. Tuples can work just like lists. They can be treated just like lists. So I could say for every element in my tuple t, if I want to print that element, that works as well. You could iterate over it. Okay, so nothing complex until now. There is one more thing left to be covered. It's the list. List. It's the dictionary. Okay. If we are clear on what we have covered so far, I would be talking of lists. I'm real sorry. I'm talking of dictionaries. So what is the definition of dictionary? Dictionary is a key value store where you have got unique keys, and every key would be having its own value associated to it. Make sense? So if you pick up any dictionary that you know, maybe dictionary of words, there are unique words. There wouldn't be a single case where you'd be finding multiple words written and multiple definitions written for that. You'd be having one single word, and one single word would be having some definitions associated to that, right? Similarly, you could place the data along with the keys in Python. It is also called as associative list. The list that does not have any indexes but keys is dictionary. How do you define it? D equals to, now in this case we use curly braces, not parentheses, not square brackets, not quotes. Then the key with some value. Again, here the keys can be any objects and your values can be any objects. It doesn't have to be one. Key doesn't have to be A. You could place number as the key, okay? Or you could place a string, a long string, or just any other object, maybe a list or a tuple here as a key. Dictionaries are also used for writing sparse matrices. So let's talk of it later on. But here I'm writing some keys and those keys would be pointing to some values. Okay, can I access it? It says key error. So definitely it does not behave the same way as lists and tuples or strings. Indexes does not start with zero. There are no indexes, rather there are just keys. So if there are keys, can I access it like this? Yeah, so that would work. Can I change the value? I want A to be holding value 5. Yes, you could change it and now A would be holding value 5. But if you compare the declaration which says A1, B2 and C3, the order of keys is A, B, C. Now when we print it out, the order is messed up. It is A, C, B and not A, B, C. So what do you take away from this? It means that dictionaries are not guaranteed to be ordered. They are not ordered datasets. Whereas your list, tuples and strings would be ordered. They start at index 0. Lists are not ordered, the dictionaries are not ordered, but only one thing that is guaranteed here is the 1:1 relationship between the keys and values. Your C would always be pointing to 3 and B would always be pointing to 2, whatever their position is in the dictionary. There are different methods here on this object. So d.keys would give you a list of all the keys. D.values would give you a list of all the values. Then d.items would give you a list of tuples, and those tuples would be holding keys and values both. So A is pointing to 5, C is pointing to 3, B is pointing to 2, and using these items you could actually iterate over the dictionary. So how to iterate over a dictionary? You could write it like this: D, okay, so for every key and value. Now this time I'm using two variables because the tuple that is supposed to be returned would be holding two values. Just like in case of x comma y equals to y comma x, here I am assigning two values. A would go to key, 5 would go to value. C would go to key, 3 would go to value. B would go to key, 2 would go to value, and so on. So for key and value in d.items, print key, comma, value. That's how you iterate over a dictionary. So I was talking of sparse matrices. So you know that in sparse matrices, all of the elements would be zero except for a few ones, right? So if you want to represent those kind of structures here in Python, it becomes more easy with dictionaries. So in dictionary, I told you already that we could place any object, right? So instead of placing a character or a number, I would be placing a tuple. So let's say my matrix is of rank 9, where it is 9 by 9 matrix, and there are very few elements which are holding value 1 and everything else is 0. So instead of wasting space in holding all those zeros which we know would exist anyways, we would be concentrating on the one part. So I would say my element at 1 comma 3 is holding a value 1. Then my element at 5 comma 6 would be holding another value 1, and there is yet another value which is maybe 4 comma 4, and this is holding value 1. So my dictionary looks like this. How do I access it? Okay, let's access it. uh, Dictionary of give me value 5 comma 6. Okay, so now there is no colon between 5 and 6, it is a comma. So like I said, you could have anything placed as a key, any object, and you pass the object between the square brackets and you should be getting the corresponding value out. That's how you store the sparse matrices without even caring about zero. Okay. In program, you would be writing something like this. If you have a key which does not exist, in that case, you return zero. So you'll have to handle this. We'll talk of this after we finish up with the functional representation. Okay. So let's get back to the function and solve the optimization problem. So getting back to the problem was that I'm not able to calculate the Fibonacci of the bigger numbers. So let's make it more easy. What I would be doing is every time I get some answer out, I would be storing that into a dictionary just for future references, so that I don't have to calculate the Fibonacci numbers of the previously calculated Fibonacci numbers. See, what I'm talking of is, if I already know the value of Fibonacci n minus 1 and Fibonacci n minus 2, I don't need to recalculate it. That's how I would be making it faster. So what I'll do is, I would calculate these values first, and I would store it somewhere. So instead of returning that value directly, I would store it in the result, and then I would say that in my dictionary I would call it as my data bag. In my data bag, the value of n, since dictionary is a mutable data set, we could mute the state of any of the index, right? So I would say data bag of n would be holding the value of result. So next time we check that if, here we check that if n already exists, so there is an operator called in. So I would say if n is present in data bag dot keys, so if n already exists in data bag dot keys, then return data bag of n. So return the value of n from the data bag itself. If n is less than 4, return n, and so on. That would speed up the things. And where is this data bag? We need to use the data bag from outside the function so that it remains global. So I would say my data bag is actually a dictionary which is empty currently. If you want to use external variables inside the function in a global scope, okay, the variables that you define inside the function are local to the function. Okay, so if you want to use it in a global scope, you'll have to use a keyword called global and the variable name, just like in case of Java. Okay, nothing fancy here. Even C has got global scopes. So making this small adjustment here would make my function move faster. I'll have to fix it first. Let me check what's wrong. Yep, I'm not returning it. So let me return it as well. Return res. Sorry for that. Wonderful. So this Fibonacci number is 40. Now it's calculated in 0.1 seconds. Earlier it used to take 21 seconds. We were not even thinking of 45. So if I hit 45, okay, still 0.1 seconds. What about 100? Still 0.1 seconds. If I add another 0 to it, still 0.1 seconds. Okay, so by making this small adjustment here, you change the speed and the complexity of your functions. Okay, and this is called dynamic programming, where your function adapts to the data set and it grows according to it. Its experience is also increasing, the function's experience, so it's learning by itself. Next value that is coming in, it would pick it from its data bag, which is acting as its experience level. So every number you calculate, it would be storing it that into the data bag, using it for the further calculations. Every time you try to access it, it would be generating the value in 0.1 seconds itself. So the complexity here of this function has reduced from 2 raised to power n minus, 2 raised to power n into n or n square to n. So the O of this function, upper bound of this function, the complexity is O of n, the current complexity of it. Okay, there are a few more things to the function and then we will be jumping to sets. So in the coming classes, what we are going to cover is details about functions. We'll be talking of passing values, passing references, we talk of returning multiple values. We would be talking of using functions as generators. Okay, so tomorrow's class is going to be dedicated to functions, and at last, if you get time, we would be covering the sets part. Okay, I don't want you people to be just sitting and not interacting. That really doesn't work out. So please go through the ebooks that I've referred to, or at least watch the videos and try to do the things on your own so that you don't feel yourself to be lost. Okay, uh, make the best use of time and money that you are investing here on the classes. So in the coming class, I expect everyone to be ready with what we have covered till now, and at least having a few interactions with me during the class so that I know that you are getting the things that are being covered here. Because in the coming sessions, after the functions, we are going to implement a very important part here in any of the programming language that you would be eventually get paid for in your companies. It is called TDD, or test driven development. So I'm going to do some test driven development using Python here. But of course, if you first understand the things, that then only it makes sense to take it to the higher levels. All right, so I'm done from my side for today. If you have any queries or doubts, feel free to ask them. I'm still here for a good 5-10 minutes and we could take up your queries. Any questions? Anything else that you want to ask from the sessions that we have covered so far? Okay, no problem. So I would meet you again tomorrow at the same time, which is going to be 8 a.m. IST. Till then, have a good day ahead, and please make sure you go through the contents which are being presented here. Okay, have a great day ahead, and thank you for attending the session today.